In the 1980s, the world was changing. Hair was getting bigger, fashion was getting bolder, music was getting louder, and the Earth was getting warmer. Although scientists had known about global climate change, it wasn't until the late 1980s that it was finally brought to the attention of the public.
Carbon dioxide, or CO2, is a greenhouse gas. It traps heat from the sun and makes our planet warmer, which can be a good thing. But for the past 150 years, human civilization has been pumping out more CO2 than our planet can handle, and it's leading to significant changes in Earth's climate.
We know that plants help fight climate change through the natural process of photosynthesis. Using sunlight for energy, they absorb CO2, store the carbon, and emit oxygen, enabling us to breathe.
What we didn't know at the time was that the most abundant photosynthetic organism on Earth isn't a plant that lives on land, but is a tiny microorganism called Prochlorococcus that lives in the ocean.
Microbes such as Prochlorococcus are a type of phytoplankton and are responsible for nearly 1/2 of the photosynthesis on Earth. In doing so, they affect the Earth's climate and keep our planet habitable. So think about this for a second. Tiny microorganisms that you can't see that live in a place where you can't breathe are actually responsible for every other breath you and I take.
The impacts that microorganisms have in the sea were in part discovered through the efforts of the University of Hawaii's Hawaii Ocean Time Series program, or HOT.
HOT has been funded by the National Science Foundation since 1988 to monitor conditions in the Earth's largest ecosystem, the North Pacific subtropical gyre.
At the time, many thought the ocean was fairly stable and unchanging, and that the low nutrient areas of the ocean, known as gyres, were not important to global productivity. In fact, these gyres, which account for about 40% of the ocean's surface, were thought of as ocean deserts. What the HOT program has been able to do is establish a baseline allowing researchers to understand the context for what they observe in an ecosystem. In its 25-year history, the HOT program has facilitated numerous discoveries, revealing that the ocean gyres are home to massive amounts of microbes that are responsible for greater than 75% of all marine productivity. Not at all a desert.
With oceans covering more than 70% of our planet, marine ecosystems are an integral component of Earth's climate. This is why understanding how climate change will alter the ocean is critical. As carbon dioxide is released into our atmosphere, the oceans become more acidic. The HOT program has one of the longest continuous records of oceanic CO2 in the world.
Making the ocean more acidic will certainly affect many ocean species, such as coral reefs. But what will happen to the oxygen-producing microbes that we depend on so greatly? Will they adapt and survive? Future generations of scientists will undoubtedly need to continue to study the relationship between the marine environment, the health of our planet, and the effects of our changing climate.